So hello there guys, welcome back to the channel. Let's proceed with the next one. It's been few days since I did the actually it's been 2 days I believe since I continue the series. So medium level lead code 1123 lowest common ancestor of deepest leaves. So the problem statement is when the root of a binary tree return the lowest common ancestor of its deepest leaves. Okay, the node of a binary tree is a leaf. A node of a binary tree is a leaf if and only if it has no children. Well, we know that from before the depth of the root of a tree is 0 if the depth of the node is d. Sorry, okay. The depth of the root of the tree is 0. If the depth of the node is d, the depth of each of its children is d plus 1. The lowest common ancestor of a set S of nodes, okay, is the node the node A with the largest depth such that every node in S is in the subtree with root A. So let's go through this line again and let's try to decipher it. So the lowest common ancestor of a set, okay, the lowest common ancestor for a set of nodes is a node with the largest depth such that every node in that set is in the subtree with root A. Okay, we have to find an ancestor A who has the deepest leaves. For example, here 7 and 4 are the deepest leaves and the common ancestor for 7 and 4 is 2, the least common ancestor actually. Well, 5 and 3 are also ancestors for the 7, but the least common ancestor is 2. If this 4 is attached to the 0 or 6, for example, let's say 6, then the lowest common ancestor will be 5 because we have the deepest leaf at 6 and deepest leaf at 2. Or if this 4 is attached to 0, then 3 will be the least common ancestor. Now we have to think a way to first find the deepest leaves and starting from them the point of intersection which is the lowest common ancestor. Should we first find, let's take a generic approach or a simple approach to say, let's first find the depth. Instead of using it like this, let's create a class. What do we call it? Class method or instance method, whatever it is. Max th. Let's do BFS. right. Pop from the left, and if the node has left, it has the right. Now we have to count now let's return the count here. Now let's see the maximum depth first. 0, 1, 2, 3, okay, 1, 2, 3, 4, right? 1 and 3. Let's see the constants 2. The number of nodes in the tree will be between 1 and 1000, and node values will be between 0 and 1000. The values of the node in the tree are unique, okay? And that is helpful in a way. Let's now we have the maximum depth. So let's define a function. We'll see real deepest leaves. If not node Return. And let's add the level to left or right. Then it's a leaf node. If level equals to maximum depth, return okay. Now let's keep it DFS. It will make things simple. DFS of dot left level plus one. So we go left and we go right. And since we are getting something here, left if it is a leaf node and it has the maximum depth, then we'll return the node. We go back. We are returning the leaf node here. So we go back. Left and right. Open the node. Also return let's try calling it DFS of node, comma 0. Let's see. What if we keep one instead? So it is okay. Well, seems like this is working fine, so let's try submitting it. Or shall we add a few more test cases before checking out the answer? Let's think out all the different ways. So, case 1, we have two children to a single node, and case 2, we have only one children. Now, instead of having 7 here, let's keep 7 here. Now it should return 5, and in this case, let's give it to 0. Now the answer should be 3. And what other cases are we forgetting? We have only single node. There is a case where we have the single node, and we didn't have a balanced case. No, let's try it. Well, seems like it is working fine, so let's submit it. This is working good. Let's see how others doing too. So here is a DFS approach. Left comma left nodes, right comma right nodes. If right nodes is greater than the left nodes. Well, here instead of counting the thing before, they're counting it from the bottom up. So it's like we go to the bottom, and here we'll return 0 as the length, and here the depth will be 1 and 2 and 3 as we go from bottom to top. So here the none is we don't have any nodes here, and 0 represents we are at the leaf node. So left and left nodes, right and right nodes. If the right nodes is greater than the left nodes, return right. So we are choosing right. Comma right node plus 1. Or if the left nodes is greater than the right nodes, we are returning, here it is returning left and left node plus 1, which is obviously uh, counting from bottom to top plus 1. Or if the both are equal, then it is returning the node okay, great. And finally, since it will return a tuple as an answer, it is taking the 0th portion here. So if we check time wise, the complexity is not very different, and for space we are using the extra space here. So I hope you guys understood the intuition. If you like the video, upload it and share it with your friends and community. And don't forget to subscribe the channel, comment so that we'll get a better reach and we'll get a better feedback to make better videos. And thank you for choosing the channel. We'll meet you again with another video. Until then, keep learning and keep pushing hard. Goodbye, guys.